Hey there. So, today we are going to take a deep dive into optimizing the nth Fibonacci number calculation in Python, and you are in for a treat. Now, you've probably seen ways to calculate Fibonacci numbers. They're pretty straightforward with just plain recursion or loops, right? But as a software engineer in the making or an experienced coder looking to get more efficient, we want to take your skills up a notch. First off, let's make sure we are all on the same page regarding what Fibonacci numbers are. They're not just any random series of numbers, but one with fascinating properties in mathematics and nature. It starts from 2001, and each subsequent number is the sum of the two before it. Quite the neat trick the sequence plays when it comes to patterns and ratios. Now, on to Python, where I feel confident in my skills. I'd normally go about calculating the nth Fibonacci number using a simple recursive function. It's like throwing a Fibonacci sequence party, inviting each number to play with the next two until I reach n, then I sum them up. Simple, right? But let's face it, recursion with its pure simplicity starts to choke out when the numbers get too large due to redundant calculations and heavy overhead with increased function calls. Now, don't roll your eyes yet, that's where the fun part begins. Let's optimize things to speed up the process using memoization. This is just a cheat sheet where you remember previous Fibonacci numbers while generating the series. So, we cache the results, and voila! We cut down on unnecessary work. Now, we can take it a step further. Matrix exponentiation. This is for you if you crave a challenge and a speed boost because, surprisingly, you can multiply two matrices using exponentiation. And those matrices help reveal the Fibonacci sequence pattern, giving us a way to perform calculations in logarithmic time, no recursion required. That's some serious shorthand if you ask me. But let's not get too carried away. There's always something to learn, and we should continuously test our functions. We're aiming for not just efficiency and speed, but also accuracy. So, we need to make sure our algorithm holds for edge cases, like extremely large numbers or even really high values that could challenge our optimizations. Performance benchmarks become our best friends to make sure our code doesn't just become a one-trick pony. But beyond coding and optimization, it's worth realizing where the Fibonacci sequence appears in nature. From the spirals of sunflower seeds to the branching of trees, these numbers are not just math, they're beauty in patterns. So, understanding these algorithms isn't just about running codes, it's about appreciating the marvels of math in the real world. Now I haven't forgotten the part where I promised you a tutorial to optimize calculations. So I'll be spoon-feeding you all the sweet and juicy details because you deserve to feast on high-speed, efficient, and accurate code. You'll learn to craft Python functions that are not only fast but clever. By incorporating memoization and even venturing into matrix exponentiation, you'll become more resourceful. And of course, the whole community at TechLab is here to back you up. And if this chat has intrigued you enough or if you just loved hearing my excitement, then make sure to join the crew at TechLab. Subscribe, comment, discuss, and dive into the coding ocean with us there. I'd like to see everyone get their hands dirty with code. Plus, there are always fresh and interesting discussions and topics for us all. Don't forget, for the full rundown on optimizing the Fibonacci sequence in Python and exploring deep into matrix exponentiation, go over to neeraj.qzz.io and subscribe to TechLab for more insights and engaging discussions.